A teacher bought 3 identical packs of pencils, each containing the same number of pencils. She distributed the pack equally in a class of 12 students and was left with 8 pencils from the first pack. She distributed the second pack equally in a class of 17 students and was left with 5 pencils from the second pack. If she distributes pencils from the third pack equally in a class of 23 students, how many pencils will remain from the third pack if it is known that there were less than 100 pencils per pack? And this is a multiple choice question. So this is a word problem from standardized tests like GRE, GMAT, SAT. And this one is actually, back to the basics, a very simple basic question. But it's worth, revising so that in a time test, you can quickly solve this problem. So the rule or the formula that I'll start this problem with is something that was taught probably in second grade or third grade, which is dividend is equal to quotient multiplied by divisor plus the remainder. So the dividend here means the quantity you are dividing. Divisor is you are dividing amongst how many, right? So that's the divisor. Quotient is, in this particular case, when you make the division, right? And if it's an equal division, so how many integer values does each of your divisor end up with, right? And remainder is basically what is simply left with. So this is a very elementary math concept that I'll start this problem with. And if you look at what the distribution here was, so the first distribution was done in a class of 12 students, and again it's dividing equally, right? So if we assume that the number of pencils is capital P, and for the class of 12 students, when the pack was distributed equally, each student got n pencils. So we can write this: P is equal to n, so the quotient here is n, the divisor, that's the number of subjects amongst which the division is being made. So in this case that's 12. And the remainder, according to the problem, so that's the number of pencils that we're left with from the first pack, right? So that's 8. So P is equal to n multiplied by 12 plus 8. And that comes to 12n plus 8. So that's the first one that we get from this very basic rule on dividend, quotient, divisor, and remainder. So what about the next one? So we can basically do the same thing for the next one, right? If we assume that each in the class of 17 got m pencils when the division was made, so the division was equally made, so each student got the same number m. So we can write P is equal to m multiplied by 17, and then there were 5 pencils that were left, right? So this is from the second pack. So we can write P is equal to m multiplied by 17 plus 5, right? And P is still the same, right? So each pack had the same number of pencils. So P, the quantity P is identical. M, we don't know what M is, but M is just like N, it's an integer. And M and N may be different, right? And they have to be different because, we are dividing the same number of pencils amongst different number of students. So that quotient will have to be different. But we can write something like this. So P is equal to 17m plus 5. Now we have to basically spot for, what potential values P can take from, treating each of these equations that I have separately, right? And we know two things. First thing is M and N, got to be integers, right? So they're integers. You can't have half a pencil, right? So the number of pencils that each student got was an integer. So that makes m and n both being integers, right? And p, the number of pencils, we don't know what p is, but it has to be less than 100 because that's the condition given in the problem, that there were less than 100 pencils per pack, right? So what are the values that p can take from the very first equation? Well, for that we just substitute n is equal to 1, we get p equal to 20, we do n equal to 2, we get p equal to 32, n equal to 3, we get p equal to 44, and so on. And as we keep on substituting integer values of n starting with 1, these are the values of p that we keep on getting: 20, 32, 44, 56, 68, 80, 92, and that's where we stop, because for n equal to 7, we basically 12n plus 8 is equal to 12, n becomes 12 multiplied by 7, 84 plus 8, 92. So the next value of n will be n equal to 8, and for that 12n plus 8 becomes 96 plus 8, so that exceeds 100. So we are not considering that value because it's known that p would be less than 100. And similarly, we can get the possible values of p from the other equation, 17m plus 5. And for this one, we do the same thing. We keep on, putting in integer values of m starting with 1. So for m equal to 1, this is 17 plus 5, 22. For m equal to 2, this is 17 multiplied by 2 plus 5, which is 34 plus 5, 39. For m equal to 3, this is 17 multiplied by 3 plus 5, which is 51 plus 5, which is 56, and so on. And in this case, we have the set of values that are less than 100 are 22, 39, 56, 73, and 90. And once we write these set of possible values of p, of course, remembering that it has to be less than 100, right? So all we need to do is basically spot what is the common value of p in these two sets, because we know p has to be the same value, right? And in this case, it's pretty easy to spot that 56 is basically common for both sets of possible values, right? So the value of p, the number of pencils per pack, will be 56, because that's the only integer value of p that satisfies both the equations, right? And at the same time, it's also less than 100. So with that information, now the rest of the problem becomes easy. So if I have to divide 56 pencils among 23 students in the class, so it's a simple division problem, and we know the quotient in this case will be 2 and remainder will be 10. So the correct answer will be option E, which is 10.